This new brick structure can also be assessed in terms of reliability as indestructible, in terms of maintaining the performance of the technique over time. The refractory mass of the brick is calculated according to the size and working regime of the kiln. It is the volume of the voids that determine the heat transfer surface through which the heat enters the brick from the burner gases and the heat leaving the brick, which is taken up by the hot air that feeds the kiln. In the regenerator, the technological efficiency is directly proportional to the number of size of voids in the brick to make the temperature of the air blown into the kiln more efficient. The larger the voids, the larger the heat transfer surface, and therefore the more heat enters, and the faster it is transferred to the blast furnace at the higher temperature at the required flow rate. The problem is that large holes mean small refractory mass. If the mass is small, there is no possibility to transfer enough heat. This is the eternal problem of researchers and the designers for coppers of all times. How to have both large thermal storage mass and large and many voids, so large heat transfer surface.
Blast furnace, a counterflow unit, is a shaft furnace. From the outside, it is covered in welded water-cooling sheet steel casing and lined on the inside with refractory bricks. The blast furnace is filled with alternating layers of metallurgical coke and iron ore charged materials. Heated, oxygen-enriched air is introduced into the lower part through Tuyere apparatus. The heated products of the combustion along the passage of the upper part of the furnace warm the iron ore charged materials to smelting temperatures and remove oxygen from iron oxides in reduction. Carbon, silicon and other elements found in iron ore charge blend into the reduced iron, forming pig iron. Slag is formed from the fusion of waste metals. Liquid products of the smelting process run out through tap holes in the lower part of the furnace to the casting bed, where they are separated into pig iron and slag and pass along transit gutters into buckets designated for each product. Pig iron is then sent to the electric arc furnace for steel production and to casting machines, where it is poured into ingots, each with a weight of 10 to 18 kilograms. After cooling, they are sent to customers. Iron ore ingots are ecologically clean, non-toxic and non-explosive. The key features of pig iron are its special metallurgical properties, low content of harmful alloys and stable chemical composition. Pig iron has always been in demand in heavy industry, the metallurgical and machinery building sectors and mill building. It is used in large volumes in these areas, both for minor details and for large-scale products weighing hundreds of tons.